Hello, my dear boys. Hope all of you are well by the grace of Almighty. All of you are welcome to my online physics class. We are discussing on chapter 8. The name of the chapter is Reflection of Light. Okay, in our previous class we have discussed some ray diagram, three ray diagram for concave mirror. In this lecture or today's lecture we will also discuss on ray diagram of concave mirror part 2. So in this part we will discuss another three position for object for forming image of concave mirror. Okay, so let's boys discuss these three position of object for concave mirror to create image step by step. So today our first topic is when the object is placed between center of curvature and focus point. Okay, here in the figure xy is our object which is placed between center of curvature and focus point. Okay, now let us assume APB is a concave mirror. XY is our object which is placed between center of curvature and focus point. C is center of curvature, F is focus point, and P is pole of the mirror, and CFP is the principal axis of the mirror. Okay, now the ray emerging from X, parallel to the principal axis XA will go through the focus point, F after reflection. Okay, here XA is our incident ray and AD is our reflected ray which goes through the focus point. Okay, now another ray XB going through the focus point will reflected parallel to the principal axis. Okay, here XB is our incident ray and BE is our reflected ray. Here these two reflected ray, AD reflected ray and BE reflected ray are meet at a point X prime. Okay, so X prime will be the real image of X. Okay, now vertical line X prime Y prime drawn from the X prime to the principal axis will be the real image of X prime, real image of XY. So according to our discussion, XY is our object and X prime Y prime is our image. Okay, here the image is real image because the object and also the image are placed in the same side of the mirror. Okay, again this image is called inverted image because the direction of xy is upward and the direction of image is downward. Okay, so this type of image is called inverted image. Okay, and we also see that the image is magnified as the object. Okay, so position of the image is between. Here you see that the position of the image is x prime y prime. So this position of image x prime y prime is between center of curvature and infinity. Okay, and size of the image is magnified, and nature of the image is real and inverted. Okay. Now our topic is when the object is placed at focus point. Okay, let us assume APB is a concave mirror. Okay, here XY is our object which is placed in at focus point. Okay, the object, now this time object is at focus point. Okay, here C is the center of curvature, F is the focus point, and P is the pole of the mirror. CFP is the principal axis. Okay, now the ray emerging from X parallel to the principal axis XA will go through the focal point after reflection. Okay, so here XA is our incident ray and AD is our reflected ray which is goes through the focus point. Okay. Another light ray in this figure, another light ray from X occurs along the center of curvature, and reflects in the same path. Okay, another light ray from X occurs along the center of curvature and reflects in the same path. Okay, so the two reflected rays are parallel. You see that these two reflected rays are parallel. Okay, so we know that parallel ray, the two parallel rays cannot meet at any point. Okay, we can say that the two parallel rays can meet at point infinity. Okay, if we extended the two reflected ray backward. Okay, if we extended the two reflected ray backward, then they are also parallel. Okay, then they are also parallel. So the two reflected ray will meet at infinity. Okay, so here for the object XY we will get an image which will be placed or which will be occur at point at infinity. Okay, so we can say that the position of the image is at infinity. So size will be the is magnified, highly magnified, and nature of the image is real and inverted or virtual and erect. Now, what is called virtual image? If the object and image are placed in the two different sides of the mirror, then this type of image is called virtual. And what is called erect image? If the here if the direction of the image and direction of the object is in same direction, then this type of image is called erect image. Okay, so in front of the mirror, we can say that they will meet at infinity, and also in backward of the mirror or behind the mirror, they will meet at infinity. So in front of the mirror, the nature of the image will be real and inverted, and in backward of the mirror or behind the mirror, the image of the object will be virtual and erect. Okay. So in our next topic, we will discuss another position of the object, where the object will placed at between focus and pole. Okay. In this topic, the object is placed between focus point and pole. Okay, so this is the figure, ray diagram for this position of image object. Okay, so let us assume APB is a concave mirror. Here XY is our object placed between focus point F and pole P. Okay, here C is our center of curvature and CFP is principal axis. Okay, now the ray emerging from X parallel to the principal axis, the ray emerging from X parallel to the principal axis XA will go through the focus point after reflection. Okay, so here XA is our incident ray and AD is our reflected ray. Okay, another light ray from X occurs along the center of curvature and reflects in the same path. Another light ray from X occurs along the center of curvature and reflects in the same path. Okay, the two reflected rays don't come together in reality. Okay, here you see that the two reflected rays will do not come together in reality. Okay, the two reflected rays come together if we extended these two reflected ray, then these two reflected ray come together at point X prime. So x prime will be the real image, x prime will be the virtual image of x. Okay. Now x prime y prime perpendicular is drawn from x prime over expanded CP. Okay, therefore x prime y prime will be the image of xy. Here the image x prime y prime will be virtual. Why virtual? Because the object and image are placed in opposite side of the mirror. Okay, so this type of image is called virtual image, and also this type of image is called erect. Why? Because the direction of, here you see that the direction of object is upward, and also the direction of object is direction of image is also upward. So the object and image are in same direction. Okay, so this type of image is called erect image. So from this position of object we will get the image, or position of the image will be behind the mirror. Okay, behind the mirror. Okay, and image size is magnified. Okay, so you see that image size is magnified. Okay, and nature of image, the image will be virtual and erect. The image will be virtual and erect. Okay, so for all position of the object we get a image. Okay, so here the, and all positions we measure from the pole of the mirror. Okay, and for all position of the object we will get a general formula for mirror. Here the general formula, general equation is 1 by f equal to 1 by u plus 1 by v. Okay, here u is the distance of object from pole, v is the distance of image from pole, and f is the distance of focus point from pole. Okay, so this is all from today. In our next lecture we will try to discuss the uses of mirror. Okay, so until then boys, thank you.